Hi Dr. Chris, so this is my bonus video and I choose question 10 problem set 8 for this video. So now look at the first question. Sketch a DNA gel containing piece or fragment generated by amplifications of DNA from the parents. Label the size of each fragment. So mothers carry 16 repeats on one chromosome and 21 repeats on the homologous chromosome, and since it's repeat from the same 10 base pair sequence, so it's like at the same position, so they're actually two genes allelic to one another. And okay, so here's mom, here's dad, and 10, 15, clear. Mom, dad, 10, 15, 20, and 25. So 16 would be, so mom, I would use red, it would be right here, the fragments for 16, and the fragment for 21 would be right here, 21 repeat will be right here. And for dad, he has one chromosome that have 18 repeats, so this one 18, and the other one is 26 right here, 26 fragments right here. And the shorter the fragments, the farther it can go. There are actually two fragments because there are two different products come from two different chromosomes. It cannot be one fragment. And for B, identify the possible genotypes of children of this couple by specifying piece or fragmentlets in each genotype and indicate the probability of each genotype. Okay, so for mom, as I explained, the 16 repeats and the 21 repeats are allelic to one another. So right here we have heterozygous mom genotype is 2116, and for dad is 1826. And gametes for mom, because here we don't have any linkage, so two chromosomes will go through meiosis and one chromosome go to each chromosome will go to each gamete, so we will have two types of gametes. One gamete will have the 16 repeats chromosome, and the other one will have 21 repeats chromosome. And the same thing happens to father. The 18th goes and the 18th repeats in one chromosome and the 26 repeats in the other chromosome. So, and as I was saying, there's no linkage, so it's just independent separation. So one half of the gametes would be 16 repeats and one half of the gametes would be 21 repeats. And right here, one half of the gametes come from dad will be 18 repeats and one half of the gametes come from dad will be 26 repeats. So the offspring would be 21, 26, 18, 16, 20. Okay, let me clear it so it can look clearer. It's 21, 16, 18, 26, and so the gametes would be 21, 16, 18, 26, and F1 would be 21, 18, 16, 18, 16, 26, and 21, 26. So here's the offspring. Okay. And because I was saying all the gametes from mom, this one is 1/2 and 1/2, so the possibility for this offspring to occur would be 1/4, and for this offspring would also be 1/4 because 1/2 16 and 1/2 26. Multiply is 1/4 16 18, and also we have 1/2 of this. Multiply 1/2 of this would be also 1/4 for this offspring. And right here we have 1/2 this, 1/2 this gametes, and multiply 1/2 this gamete will be 1/4 for the appearance of this offspring. So 1/4 for each kind of part. And because as we can see that even with the heterozygous genotype, no alleles cover the expressions of the other alleles or take dominance on the others. No recessive, no splitate, no incomplete dominance, and both phenotypes from each genes are expressed mosaically on one individual. So it is codominant. Thank you, Dr. Gray.